Next up, let's consider a couple properties of the definite integral. Now, hopefully these properties are fairly intuitive, but we'll introduce them one at a time. So, first property. Normally, when we put down our limits for our definite integral, we see from a to b. Now, in the event that something seems awfully backwards, this is essentially saying that for your delta x, instead of going from left to right, you're going to be going from right to left. Now, if you go right to left, though, your delta x value is going to be negative. You are allowed to change it to go from left to right if you reverse the sign of the definite integral. So multiplication by a negative sign can flip the limits of your integration. You'll see this a lot in Calc 2 as well as in the substitution rules section. Something else that shows up from time to time, especially with the substitution rule, which we're still getting to, is the definite integral from a to a of f of x. At this point, your change in x is going to be 0 due to the fact that a minus a all over n would be 0. It's guaranteed that this winds up being equal to 0. And again, that might seem kind of nonsensical, but it happens from time to time. So, next thing is, if I take the definite integral from a to b of a constant, I'd like to draw a picture of this. Here's y equals a constant, here's a, here's b. The area that we'd be looking for would be the area of this particular rectangle. Now with that in mind, area of a rectangle is going to be the height times the length of the base. That's where c represents any constant, positive or negative. If you take the definite integral of a sum of two functions, then this can be expressed as the sum of the definite integrals of the functions. That's an a, this is a g. The same will work for the subtraction of any two functions. So if we have f of x minus g of x, this can be expressed as the definite integral from a to b of f of x dx minus the integral from a to b of g of x dx. You'll notice that the last two rules look very similar to the rules that we have for derivatives. They are not unrelated. Additionally, if we have a constant multiple for our definite integral, that also works the same as the rule for derivatives, which is take that constant multiple and move it outside of the definite integral. And that's where, again, c represents any constant. And one last property says, suppose that you want to consider the definite integral from a to b of f of x dx. Now we should have a pretty good picture of what that looks like. Generic looking function here, a to b. We're looking for all of the area underneath the function. Now suppose, for the sake of argument, that there is another number, c, somewhere in the middle of this interval. Hopefully it makes sense that if I were to say, find the area from a to c, and then add the area from c to b, that makes sense. That would be the definite integral from a to c of f of x dx plus the definite integral from c to b of f of x dx. Now, to give you an example of how some of these properties work, I would like to have you consider the following situation. The definite integral from 0 to 9 of f of x dx is going to be equal to 12. The definite integral from 0 to 3 of f of x dx is equal to 4. If I asked you to find the definite integral from 0 to 9 of 6 times f of x dx. Recognizing that 6 is a constant multiple, it can be pulled outside of the integral, and this could be 6 times the definite integral from 0 to 9 of f of x dx. We have something for this. That would be equal to 6 times this, 12. If I asked you to find the definite integral from 3 to 9 of 8 times f of x, then this is going to require a couple of rules. Now you'll note that going from 3 to 9 isn't listed for either one of these. So the thing that I would like to point out is that if I were to take the definite integral from 0 to 3 of f of x dx, and then add to it the definite integral from 3 to 9 of f of x dx, then according to the last property on the previous page, I would get the definite integral from 0 to 9 of f of x dx. Given that this is equal to 4, and given that this is equal to 12, we can use algebra to figure out the value of the definite integral from 3 to 9 of f of x dx. This would be equal to 8. Now, as that relates to what we're doing here, if I were to use the same property for this as what I used on the last one, I could take that 8 and factor it outside of the definite integral. And using the algebra that I just did here, that definite integral is equal to 8. 8 times 8 gives us our final answer of 64.